So here we have chapter 4, alkanes and cycloalkanes. So hydrocarbons are molecules that only contain carbon and hydrogen. Alkanes are hydrocarbons that don't have a double bond, and so there are no pi electrons. So we have 3 examples. All of the alkanes are going to end with A-N-E. Propane has 3 carbons, butane has 4, pentane has 5. Now initially, compounds were named at the whim of their discoverers. So we have formic acid, and formic acid was first discovered or isolated from ants, and so it's named after the Latin word for ants. Urea was originally isolated from urine. Morphine was named after the Greek god of dreams, Morpheus. And barbiturates were named after a woman named Barbara. As you can see, this would quickly become unworkable. We've got so many organic compounds that we're going to need systematic names. And so the International Union of Pure and Applied Chemistry, IUPAC, that's the International Union of Pure and Applied Chemistry, developed systematic names. And so the first step in developing a systematic name is to find the longest chain. And we call that the parent chain. And that's the parent. And then we name it using this table. So if it has 1 carbon, it's a meth, and if it's a hydrocarbon, it would be methane. Ethane, eth is 2 carbons, pro is 3, but is 4, pent is 5, hex, and then we get down to hept and oct and nonane for 9 and dec for 10. You'll need to know these in order to be able to name compounds. If there are 2 chains of equal length, the parent chain will be the one with the greater number of branches, or we call branches substituents. So let's see an example of that. We have 2 compounds here. Actually, we have the same compound, but we have drawn 2 different parent chains in here. This one has 3 substituents. It's got this branch, it's got a branch there, and it's got a branch there. The other one only has 2 branches. So we'll want to make the parent chain have the most branches. Oops, branches. Okay, we also need to name cyclic compounds, and we do that by just putting cyclo in front. So this is a 3-compound compound that's in a circle, so we'll call it cyclo, and it's propane because it's 3 carbons. And it's INE at the end because it's an alkane, no double bonds are present. This one has 4 carbons, and we'll call it cyclobutane. And this one has 5 carbons. It's in a circle, so we'll call it cyclopentane. Okay. So our next task here is they've asked us to identify and name the parent in each of the following compounds. So we're just looking to find the longest chain that has the most substituents on it. So here we go, 1, 2, 3, and we've got, let me get a different color. 1, 2, 3, 4, 5, 6. So this is a hexane. This next compound, we could start here, but if we do that, we'll get 1, 2, 3, 4, 5, 6. And if we start here, we'll get 1, 2, 3, 4, 5, 6, 7. So we're looking for the longest one, so it'll be a heptane with 7. Here we get 1, 2, 3, 4, 5, 6, 7. This is another heptane. We're just finding the longest chain. The longest chain does not have to be in a right to left configuration. In letter C, the longest chain is going to be not these 1, 2, 3 carbons, but it's going to start here with 1, 2, 3, 4, 5, 6, 7, 8, 9 carbons. So this is a nonane. And so they don't have to be drawn right to left. This one that's the longest chain. Okay, so after we find the longest chain, we're going to have to name the branches of the substituents. The branches of the substituents are named by adding an ly to the parent name. So for the compound that's given here as an example, this is our parent chain. And then we have these branches, or these substituents. We've got an ethyl group. It's got 2 carbons. We've got a propyl group with 3 carbons, and a methyl group that just has 1 carbon. So these groups are named very similarly to the table you were given before. If you have 1 carbon, it's a methyl. 2 is an ethyl. 3 is a propyl. 4 is a butyl. 5 is a pentyl. 6 is a hexyl, and so forth. You don't usually see them really above a pentyl. Okay, so let's look at this example and see if we can find the parent chain and then figure out what substituents are present and how each substituent should be named. So for the parent chain, we're going to come here, here, here. So the longest is going to be here. That's going to be a dead end, so we better come up here, here. Okay, now we can go this way and get 2 carbons. We can go this way and get 2 carbons. If we come to the lower part, we'll only get 1, 2, 3, 4 substituents. So let's go up, and that way we'll get 5 substituents. And I'm going to get some different colors out here. We've got several here that are methyls. This just has 1 carbon. This just has 1 carbon. And that just has 1 carbon. So I've got 3 methyls. And let's get out pink. Oops. Sorry about that. And here is, I've got 2 ethyl groups. 2 That's how we would name those. Let's look at the next one. We've got to find the longest chain first. Here, here, here. And then we have to decide which branch to take. This one's going to be longer, so we'll take this one. And that leaves us with two groups. We've got this one, and it's got 1, 2, 3 carbons, so that's a propyl. And we have this one that has just 1 carbon, and that's going to be a methyl. Okay, now sometimes as these branches get more complicated, the branches have branches. So in this case, in this example, you'll see the main chain, and then this is our branch off the main chain, and our branch has a branch. And so we would name this branch with the, let's get the right color. It's got 4 groups on it. So we would say that was a butyl, and our butyl has a methyl on the second carbon. So it would be a 2-methyl, and I just misspelled that. Okay, methyl butyl. And we put brackets around it because the whole thing is a branch. There are some common names for these branches, and they're worthwhile memorizing because you will be using them quite a bit. So the common names, if you have a propyl, you can have 2 different forms of it. If this is the parent, we'll do that in green. Your propyl group can come off just as a chain, 1, 2, 3 carbons, 1, 2, 3. But you can also, this is the parent, you can also have a propyl group that comes up. Here's 1, here's 2, here's 3. So you can make a little Y with it. So these are named, the common name for this branch is isopropyl. And the common name for this one is propyl. The IUPAC name for this would be to number this and say this is carbon number 1 and this is carbon number 2. And so what we have here is a 2-carbon chain with a branch on the first carbon. And so we would call that a 1-methyl, and it would be a 1-methyl, and these are 2, so that's ethyl. It's a 1-methyl ethyl with brackets, and that's how you could name that substituent. If you have 4 carbons and you have a butyl group, you can make even more different, you can make even more different arrangements of atoms. So here's the parent, and if you have just a plain old butyl, you'll have 1 carbon, 2 carbons, 3 carbons, 4 carbons. So you have your 4 carbons and they're in a line. But you can also have one carbon, 2 carbons, 3 carbons, and we get a methyl group off that first carbon. This is called a sect butyl. It can also, we can number these 1, 2, 3, and say that we've got a 1-methyl, propyl. All right, so we also can put that methyl group on the second carbon. There's our parent. Come out here. And this is an isobutyl. You'll see iso whenever you see that little fork at the end, the isobutyl. And this would be a 2, we'd number these 1, 2, 3. So this would be a 2-methyl propyl. The third one is the most famous and the one you will see the most. There's our parent. And I'll move over, make sure you can see this one because this one's important. It can come out and we can get, and that's called a tetrabutyl or a tert butyl. And if you were going to name this with the IUPAC name, you get 1, 2. So you have an ethyl that has 2 branches on it. So we call this a 1,1 dimethyl ethyl. But nobody calls it that. They just call it a T-butyl, is what they call it. Okay. I didn't leave myself enough room to talk about pentyl. And we're not going to draw all the possibilities for a pentyl. Pentyls, of course, have 5 carbons in their branches, and so they can be just a straight 1, 2, 3, 4, 5 pentyl. You can have an isopentyl, which is going to have that little forky thing on the end. 1, 2, 3. There's our 5 carbons, but they've got a fork on the end, so that makes it an isopentyl. If we wanted to name this with the official naming system, we'd put numbers on this, and we'd say we have a branch, a methyl branch on the 3rd carbon. So this would be a 3 methyl, and it's a butyl. And here we have the last one, which is a neopentyl, which is comes out like this, go up, and looks a little like a T-butyl, but it's, and we call this a neopentyl, and it's a 2,2-dimethyl, and it's a propyl. We've got 1, 2, 3.